Hey everybody. Okay, so we're going to continue our work, and what I'd like for you to do first is I'd like for you to draw a diagram that represents base 10 blocks if we were going to be multiplying this problem. Okay, so if you took 280 here at ASU or a similar class at another college, they may have gone over this with you. I know that our 280 classes do. So think back to what you remember about base 10 blocks when we're trying to multiply problems that look like this. And I don't expect you to have base 10 blocks with you, but I would like for you to try and draw what it would look like if you had base 10 blocks, what you would build if you had base 10 blocks. So I'm going to ask you guys to pause for a second and then draw whatever it is you're going to draw, and then we'll come back together and talk about it. Okay, so hopefully you had a chance to draw something there, and I'm going to go ahead and show you with actual base 10 blocks what it would look like. I'm not sure where we're kind of at with our understanding of base 10 blocks. So I'm going to go ahead and build this. So these are base 10 blocks, right? So here is a 10, and the reason it's a 10 is because there's 10 of these units that would fit inside of this, creating a 10 there. We also sometimes call it a long. So that's a 10. So this would be the number 12 that I have here. And I'm actually going to build it off of the board because it fits better. And then going across this direction, we would have, actually I'm going to switch this around so it looks like this. There we go. That's better. Okay, so there we go. So now I've got my 10 going across the side and 10 across the top. Okay. And so now I've got 10 here and 13 there. And so basically what I'm going to do is on the board here, I'm going to try and build what that would look like, right? So if I have a long right here, a 10, I'm going to need 10 of those to fill in this whole area right here. And when we have 10 of those, we call that 100, or a flat. We call that 100. So this red one here is taking into account all of these 10 and all of these 10. If I filled them in, that's what it would be. And then here, I'm going to need a long that goes like that, and another long that would fit right there for that unit and that long. And then I need another one for right there. So I'm going to have 3 more 10s that are going to sit right there. Then I'm going to have another 10 that sits over here. And this 10 is for that unit and that 10 up there. So that's going to be one of those. And then the last thing I'm going to have is I'm going to have some units that are filled in right here. So if your class used base 10 blocks, this is probably one of the ways that you learn to multiply base 10 using base 10 blocks. Obviously, it's not a super efficient way to multiply because nobody walks around with base 10 blocks in their pockets, right? But it certainly works. And so now I'm just going to pull this away a little bit and pull this away. And so you can see the answer is actually what's on the board here, right? So this is my answer. So if I count this up, I would see that I have 100 plus 10, 20, 30, 40, 50, and then 6. So that equals 156. And this is how we can show multiplication. And so what I like about this is that this shows students at a very young age, say 3rd grade, that every time we multiply 2 numbers together, we're creating a rectangle. And that's something I want to emphasize a lot. So every time I multiply 2 numbers together, the shape that's going to be made by those 2 numbers is going to be a rectangle. It's base times height, base times height. And the area of this rectangle would be 156. Okay? All right, so that's if we had base 10 blocks, which I didn't expect anyone to have base 10 blocks. So now I'll go ahead and draw what you may have drawn, right? If you remember this is probably what you would have drawn. If you didn't remember it, you probably did not draw this at all. So what I'm going to do then is I say, okay, well, there's my 10, and then 2 more units, right? So there's my number 12. From here to here is 12. a 10 plus 2 more. And then here is another 10, and then 3 units. So that's the number 13. Goes from there to there. So I drew what these things kind of represented, right? So I just kind of drew it out there. And now, the way I used to have my students do this is anywhere that I started drawing a line, so I started a line there, 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 I'm going to continue that line. So this blue line, I continue going straight down. And then this pink line, I continue going across. And now I know kind of how long they're going to be. So now I just keep continuing those lines just like that. So anywhere I started a pink line, I continue drawing it out. And then anywhere that I started a blue line, I continue it going down. Just like that. And when I do that, what I'm left with, or when I'm done, is I have, there's my 100, and there's a 10, 20, 30, 40, 50, 51, 52, 3, 4, 5, 6. So I end up with 156. Of course, we already knew it was 156, but that's what you could have drawn. And this drawing is a representation of using these tiles like this. Okay? So this is perfectly acceptable, and this is what I'm hoping that we'll be able to do with certain things. Here's what I don't want you to do. So even though it's going to give you the same answer, right? So you do this. And this. Okay, like that. And then what I don't want you to do then is to go back and go, okay, there's that one, that one, that one. Okay, so I don't look at these two things as equivalent, even though they both give us 156. This is not quite done as well. And the main reason it's not done, there's two reasons really. It's slower, right? It takes kids a lot longer to actually draw the individual squares versus what I did. And the second thing is, you can see I didn't line it up real well. And some students might start to lose track and they might not put in all of the units that they need because maybe they don't line them up directly underneath or whatever. So it's just more chances for them to make a mistake if they draw each individual box like that. So my preference is for them to start the lines and draw them across, and when they're done, it will naturally create the answer for this case, which is 156, okay? Okay, so we're gonna build on that, right? We're gonna build off of exactly what we just did there, except that I forgot to tell you that I actually screwed this problem up. I didn't really want you to do 12 times 13. What I wanted you to do was x plus 2 times x plus 3. I didn't mean 12. I don't know why I wrote that down. That's kind of weird. Now, some of you, again, are probably immediately going to the 4-letter F word, right? You look at this and you go, oh my gosh, I hate these. These are and then you just want to start using and swearing and using language that I don't think is appropriate for a math classroom or any classroom for that matter, but certainly not a math classroom. So I'd prefer us not use that language, right? We don't want to use the 4-letter F word when we're looking at this. And instead, we're going to use, language that is going to be more appropriate. So, what I want to tell you is if you look at this, if x equals 10, then isn't it 12 times 13? If x equaled 10, then it'd be 12 times 13. So if this problem is equivalent to that problem, then I should be able to do this problem exactly like I did it over here. Well, exactly like I did it right there. I don't want you to do it like this one, but exactly like I did here, because these two are equivalent. So this, whatever you might think about it, is nothing different than this problem. So the way I do this problem is how I can do this problem. So I'm going to go ahead and do this problem over here. So I have a little bit different tile here. And you see that it's not a 10, right? It's not a 10. It's something other than a 10. So let's see what it is though. We called this one a 10 because there were 10 units that lined up next to it. But here, I don't think I certainly don't have 10 units that are gonna line up. Let's see how many it is. See if we can figure out what this thing is gonna be called. All right, so there we go. So the question is here, what do we call the green one, right? So if we call this one a 10, because 10 units lined up, what's that one called? And I'm gonna go ahead and slide it over just a tad. There we go, and like that. And so you might be going, well, it looks like it's a 1, 2, 3, 4, 5. So I'm gonna go ahead and all nice and lined. Okay, I'm gonna go ahead and zoom in a little bit and see what we see. That's all the way zoomed in. All right, so let me lift this then. So what do you think? Does it really look like it's perfectly lined up there at the end? Oh, not really, right? It's close, but it's not quite exactly right. And so you might be thinking, man, Milton Berger is so friggin' cheap because he couldn't even afford to buy the screwed up tiles. He got them off. He got these off the half price rack, so because they were defective, which is normally 100% true of me. Like if you see my clothes, I'm probably wearing stuff that's got flaws in it because it's a lot cheaper. But it's not actually the case in this. This is not incorrect. I mean, this is not built incorrectly. It's actually designed like this. The designers of this do not want you to think that there is a number of these tiles that exactly equals this green one. They don't want you to think that. It's a little bit off. It's supposed to be that way. And so one year I had some students who, these girls were determined to figure out what the ratio was between the green and the units. And so they got a desk out, a couple of tables, and they started lining these up next to it. And then the other girls there's like 3 of them lining up the units, and they kept stretching out longer and longer and longer. They wanted to see how many of these units, how many of these longs fit with these units. And they got out to 37 of these. And they were not convinced that it was perfectly lined up at the top up there. 37, they still weren't sure. I thought for sure they were gonna come up with it, before that, but they kept looking and nope, it's not quite right, not quite right. And they said, so they didn't even think that 37. So these things are really well engineered, right? So they're supposed to be, we're supposed to realize that there is not a number of these yellow ones that perfectly lines up with a green one. Okay, so that means if it's not a 10 or it's not a 5, then what do we call it? Well, obviously we don't know what we call this. We don't know what that is, right? I said it's not any number of these. And what do we call things that we don't know in math? Like what do we use when we don't know something in math? What do we do? We call it X. That's exactly right. So this from now on is going to be called an X. So then if I'm trying to build X plus 2, then I've got X there, and then I've got 1, 2, just like that. And then if I'm trying to build X plus 3, then I've got my X there, and 1, 2, 3, like that. So, just like that. So now I can start filling it in. And so the shape I'm going to use to fill in this part, just like when I did my base 10 blocks, I used a big old square like that we called a flat or 100. I'm going to use this one because that one's going to line up perfectly and fit right in there. So this, because it's X times X, is what an X squared looks like. This is an X squared. Look at the shape. Look at the shape of that. What shape does that make? It makes a square. That's why we call X to the second power X squared, because it makes the shape of a square. And then I'm going to need 3 of these in here. So there's 1, and these are X's now. 2, 3. And notice I'm not lining them up like this, right? Because that doesn't make any sense. I'm going to line them up the side that matches, like a puzzle, with the side that matches. So the long side with the long side and the short side with the short side. And then I need a couple more over here. So I got one there and one there, just like that. And then I need to fill in this box right here. So I've got 1, 2, 3, 4, 5, 6. Okay, there's my 6. I line those up and bam, there is my answer. And you notice that it looks very much like our base 10 blocks. Instead of having 100 here, we got x squared, which by the way is what 10 times 10 is. 10 times 10 is 10 squared. 10 squared equals 100. So there's my x squared. There's my 3 x's, which are like those 3 10s there. Here's my 2 x's, like those 2 10s there. And then 6 units, just like that. So remember, these are not part of my answer. Those are the length and the width of this rectangle. Okay, so there we go. So if I wanted to build it, that's what I would build. Okay, now, what if I wanted to draw it like you have there? I'm gonna do the exact same thing we did before, except instead of calling that a 10, it's going to be an x. So there we go. There's my x, and then 1, 2. Then going this way, I've got my x. Whoops, well, I put a 10 in there. Durr. And then 1, 2, 3. And now, anywhere I start a line, I draw the line, right? So I got that one. I start a line down here, and now I know where to finish so that it looks nice and satisfying. There we go there, and there. And then drawing these, starting where those ones started, I continue going down, going down, going down, just like that. And so what I'm left with is, this isn't 100, it's now x squared, because x times x gives me x squared. X times 1 gives me x, and then x, and then an x, and then an x, and then an x, and then dunk, 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 dunk. And what we'll notice is, just like these 10s and these 10s could add together to give me 50, these x's and these x's could add together to give me 5x. So what I have here is x squared plus 5x plus 6. 1, 2, 3, 4, 5, 6. And that is what this is equal to. Okay? So that's if we want to show using the tiles, algebra tiles. Okay? In the next video, I'm going to show you the next way to do it is what if we don't want to use the algebra tiles and we want to use an even shorter way of doing this. But this is how we do it if we want to be able to show each individual tile and draw it in there, how it would work and then what it would give me. So you can see that back in 3rd grade when you're teaching multiplication, if you use this with your students, it'll make the transition in algebra much easier because they can then use this very easily. If not, then I have to go back and teach this to them so that they understand how to do it over here. Okay? All right, so that is the second part of this. And then we got one more, and that'll be it.